What is the most extreme object ever discovered in the universe? Not the tallest mountain on Earth, not the fastest hurricane, not even the most powerful nuclear explosion. No, these belong to the small world we inhabit. Out there, beyond our planet, lies a cosmos where extreme takes on a different meaning. It is not measured in kilometers or joules or even lifetimes. It is measured in billions of suns, in the collapse of space-time, in scales where the very laws of physics disintegrate. The universe is filled with marvels that already defy our imagination. Stars 1,000 times larger than the sun, explosions that outshine entire galaxies, black holes that could swallow our solar system whole. But among these wonders, there is one object that stands above them all. One monster so vast, so dense, so alien, that it redefines what we mean by extreme. This is the story of that object, how we found it, why it defies comprehension, and what it means for our place in the cosmos. But to truly understand why this object is the ultimate extreme, we must first climb the ladder of cosmic extremes, from the familiar to the impossible. Before we continue deeper into the universe's extremes, if you enjoy exploring these mysteries with us, consider subscribing. It's a small action, but it helps us keep diving into the biggest questions of all. When humans first gazed at the night sky, the stars appeared timeless, pinpricks of light, eternal and unchanging. The ancients saw them as gods, ancestors, or jewels embedded in a celestial dome. But with science came revelation. Stars are not eternal. They are born, they live, and they die. And their lives, violent, beautiful, brief, or long, span scales beyond our comprehension. Our sun seemed immense to early astronomers, but in truth it is modest. Among the stars it is average. There exist stars so colossal they make the sun appear like a grain of sand beside a mountain. Take VY Canis Majoris, a hypergiant star. If placed at the center of our solar system, its surface would extend beyond the orbit of Saturn. Imagine standing on Earth and looking upward, only to find not the blue of sky, but the burning red of a star's surface, filling the entire heavens. Stars like these are unstable, doomed to collapse in spectacular fashion. When their fuel runs out, they explode as supernovae. These explosions are so powerful they can briefly outshine entire galaxies. Chinese astronomers in the year 1054 recorded one, a guest star that lit the sky for weeks before vanishing. What they saw was a massive star tearing itself apart, leaving behind the Crab Nebula still visible today. But even the supernova is not the end of extremes. At the heart of some explosions, matter collapses so violently that protons and electrons fuse into neutrons, creating a neutron star, a city-sized object containing the mass of the sun. A teaspoon of neutron star matter would weigh more than a mountain. Some neutron stars spin at dizzying speeds, hundreds of rotations per second. These pulsars sweep beams of radiation across space, ticking like cosmic clocks, their precision unmatched by any human invention. And then rarer still are magnetars, neutron stars with magnetic fields 1 trillion times stronger than Earth's. If a magnetar were as close as the moon, its magnetism could erase every credit card on Earth and distort the very chemistry of our brains. When they flare, they release more energy in a fraction of a second than our sun will emit in 100,000 years. Each of these steps feels final. The hypergiant, the supernova, the neutron star, the magnetar. Surely we think nothing can surpass this, and yet the universe had one more trick. It created black holes. A black hole is not simply an object. It is a region of space where the rules we know no longer apply. When a star much larger than our sun collapses under its own gravity, it can shrink beyond all limits. The result is a singularity, a point of infinite density, wrapped in an event horizon, the boundary from which nothing can escape, not even light. To fall into a black hole is to vanish from the observable universe. To an outside observer, you would appear to freeze at the edge, your image stretched and reddened until it faded away. But for you, crossing the event horizon would feel strangely uneventful. You would drift past, unaware of the moment, until tidal forces shredded you and time itself collapsed toward the singularity. Black holes come in many sizes. Stellar black holes, a few times the mass of the sun, form from collapsing stars. But then came a shocking discovery. At the centers of galaxies lurked supermassive black holes, millions, even billions of times the mass of the Sun. How could such monsters exist? And what did they mean for the galaxies that surrounded them? These were not passive objects. They shaped galaxies, consuming matter, and spewing out jets of energy that could stretch across millions of light years. Some shone so brightly that they could outshine their host galaxies. Astronomers gave them a name, quasars. And among the quasars one stands apart. In the 1950s, astronomers surveying the skies for faint radio signals stumbled upon something extraordinary. A quasar so bright, so distant, that it defied easy explanation. Its name, TON 618. Located more than 10 billion light-years away, TON 618 is among the most luminous objects ever observed. At its heart lies a black hole of unimaginable size. Estimates place its mass at 66 billion suns. Try to picture that. Our sun is already so massive it makes Earth seem like nothing. Place 66 billion suns together, and you would have something beyond imagination. Compress that into a single black hole, and you have TON 618. Its event horizon, the boundary of no return, is vast. Light itself would take a week to travel across it. Entire solar systems could vanish inside unnoticed. TON 618 shines with the power of 140 trillion suns, and yet what we see is only the byproduct of destruction. Gas and dust spiral into its maw, heated to such extremes that they radiate across the cosmos. The black hole itself remains invisible. When we look at TON 618, we see it not as it is today, but as it was billions of years ago, when the universe was young, a monster that has been feeding since near the dawn of time. If we are to speak of the most extreme object ever discovered, TON 618 wears the crown. But what if you fell in? Approaching TON 618, you would be dwarfed by the scale of its accretion disk, a glowing whirlpool of gas and dust heated to millions of degrees. Radiation would cook you long before you neared the horizon, but imagine you could survive. Closer in, time itself would stretch. To a distant observer, you would slow, frozen in place. But from your perspective, you would drift onward. At the horizon, nothing announces the crossing. No wall, no boundary you can touch. But once you pass, escape is impossible. Inside, gravity would guide you toward the singularity, a point where density becomes infinite and space and time collapse. What happens there is unknown. Some physicists argue reality ends. Others suspect quantum mechanics prevents a true singularity, replacing it with something stranger, perhaps a quantum bounce or a bridge to another universe. Inside TON 618, the truth may lie waiting, but no signal can escape to tell us. Is TON 618 the ultimate extreme, or simply the most extreme we've found? Theoretical physics whispers of stranger things. Some imagine primordial black holes, ancient relics of the Big Bang scattered invisibly through space. Some may be no larger than atoms, yet heavier than mountains. If they exist, they could be dark matter itself. Others dream of white holes, the theoretical opposites of black holes, which expel matter instead of consuming it. No evidence has been found, but in mathematics, they are possible. Could our universe itself have begun as a white hole explosion? Loop quantum gravity predicts Planck stars, collapsed objects that never form singularities, instead rebounding into bursts of energy. If true, black holes may not be eternal graves, but ticking time bombs, waiting to explode. And then there are wormholes, speculative bridges between distant points in space and time. Some scientists suggest black holes might hide wormholes inside. If true, TON 618 could be not just a monster, but a doorway. The quest for the most extreme object is more than curiosity. It is a confrontation with the limits of knowledge. Black holes test the boundaries of physics. General relativity predicts them, but inside their depths, quantum mechanics must rule. Where the two theories meet, they conflict. In that conflict lies the key to the next revolution in science, the unification of gravity and quantum mechanics, the long-sought theory of everything. In this sense, TON 618 is not just an object, it is a clue, a riddle left by the universe daring us to solve it. Look beyond the familiar stars, beyond the reach of our telescopes, and into the depths of space. Across billions of light-years, TON 618 waits, a black hole so immense it swallows light, time, and matter itself. A monster that existed when the universe was still young, feeding relentlessly, shaping galaxies in its invisible grasp. And yet, TON 618 is not the end of extremes. It is a doorway into questions that may never have answers. What does it mean for us, small beings on a pale blue dot, to contemplate such incomprehensible forces? Perhaps it is a reminder of our humility, of the limits of perception, of the vastness of a universe that continues to defy understanding. TON 618 challenges more than physics. It challenges imagination. It challenges philosophy. It challenges us to ask, what else is out there that we cannot yet see? What other extremes await discovery? In this way, the most extreme object in the universe is not just TON 618. It is a mirror reflecting our curiosity, our drive to know, and the infinite frontier that lies ahead. The universe does not end with a single discovery. It stretches onward, stranger and more beautiful than we can imagine. And as long as we continue to look, to question, and to explore, the edge of understanding will always be just ahead, waiting for us to reach it. If you've enjoyed this journey through the universe's extremes, consider subscribing. It's a small action, but it helps us continue exploring the biggest mysteries of the cosmos together.